morning. My name is Muhammad Khairul Ikmal bin Yahya. Today I would like to present to you about protective coating. I'll introduce myself. My name is Muhammad Khairul Ikmal bin Yahya and my metric number is DB 106120. We are from group 2. Firstly, we are going to a type of corrosion. There are as many different types of corrosion, each of which can be classified by the cause of the metal chemical deterioration. Firstly, we are going to uniform corrosion. Uniform or general corrosion are defined as a type of corrosion attacks that is more or less distributed over the entire exposed surface of a metal. As you can see, the shape on the slide, uh, that the surface of the ship is a uniform corrosion. Corrosion is the variable of corrosion is a time and then a chemical reaction on the surface. Next is galvanized corrosion. As you can see, galvanized corrosion is the accelerated corrosion of a metal because of contact with a more noble metal in an electrolyte. Galvanic series of metal and alloy is used for production of this type of the corrosion. As you can see on the slide, the base metal is a galvanized material and the screw uh, is a carbon steel metal. This corrosion uh, this corrosion because of the between of the material. Usually, this corrosion is happen at the starboard or maybe the screw in the base material. Okay, now we are going to pitting corrosion. What is pitting corrosion? Pitting corrosion is an localized phenomenon confined to smaller areas. Pitting corrosion are normally found on the passive metal and alloy, such as aluminum alloy, stainless steel, and the alloy when the oxide film is chemically or mechanically damaged.
Okay, next I will be explain about type of corrosion on pipeline in oil and gas industry, which is number one is pitting corrosion, number two uniform corrosion, and galvanic corrosion and reverse corrosion. Next, for the salt spray testing, there is five testing that will be conducted for this corrosion, which is NXA1, NXA2, A3, A4, and A5. For the A1, it will be exposed to a continuous indirect spray of acidified pH 3.1 to 3.3 saltwater solution, and for the A2, it will be 0.75 hour exposure to a continuous indirect spray of acidified pH 2.8 to 3.0 of saltwater solution. For the A3, there will be 30 minutes exposure to a continuous indirect spray of acidified pH 2.8 to 3.0. For the A4, there will be two changing climate cycles. The first climate cycle comprises of a continuous indirect spray of neutral, which is have a pH 6.5 to 7.2 of saltwater synthetic seawater solution. The second climax, it will comprises of 0.5 hours of continuous indirect spray of neutral, which is pH 6.5 to 7.2. For the A5, it will be exposed to a changing climate that comprises of the following two-part repeating cycle, which is 1 hour's exposure to a continuous indirect spray of dilute acidified, which have pH 5.0 to 5.4. And this is followed by 1 hour exposure to an air drying or purge climate in a chamber temperature of 35 degrees Celsius. Okay, next, for the application of salt spray testing, uh, for the A1, it's suitable to test the relative resistance to corrosion of decorative chromium plating on steel and zinc-based die casting. And for the A2, which is cyclic acidified salt spray test, it's suitable to test the relative resistance to corrosion of aluminum alloys when exposed to a changing climate of acetic acid salt spray. And for the A3, which is seawater acidified test, cyclic, is suitable to test the relative resistance to corrosion of coated or uncoated aluminum alloy and other metals when exposed to a changing climate of acidified synthetic seawater spray. And for the A4, it's suitable to test the relative resistance to corrosion of product samples that are likely to encounter a combined salt spray and acid rain encounter. And for the A5, it is suitable to test the relative resistance on the paint on steel. And for the pitting corrosion, it will conduct a seawater acidified test cyclic, which is A3, which is suitable to test the material for the subsea water piping.
Next, I would like to present about the causes of the pitting corrosion. Pipelines, well, and fittings are susceptible to corrosion because they are typical construct from various grades of carbon steel. Pitting in pipes and well is made possible mostly due to the weak spot in the metal natural precipitating protective oxide film. In the oil and gas industry, corrosion is frequently the result of chemical reaction between CO2 and H2 and steel, with water usually acting as the catalyst for the reaction. Overall, the most common type of oil-field corrosion responsible for pitting are sweet corrosion, sour corrosion, oxygen corrosion, and crevice corrosion. Now, we look at the figure of the pitting corrosion. This is the example of pitting corrosion that occur in pipeline. This is a figure shows how the pitting corrosion happen in the pipeline. Next is the variety types of pitting corrosion that occur in industry. The first type of pitting corrosion is sideway pitting corrosion. There are two types of sideway pitting corrosion, which is the horizontal grain attack and the subsurface. Here we can see the difference between the two types of different sideway pitting corrosion. Next is true pitting corrosion. There are 5 of them. True pitting corrosion. The first one is elliptical, which is when the corrosion happen, it make the ellipse shape. And the next true pitting corrosion is undercutting, which is from the surface view, it seems like a small corrosion, but inside there were bigger corrosion. That's what called undercutting true pitting corrosion. Next is narrow and deeps. We can see here that the corrosion is happen deep inside the pipes. Next is the shallow and wide. It's a shallow corrosion, but it's wide area of the surface. And finally is the true pitting corrosion vertical grain attack. Next, I will present about the characteristic of pitting corrosion. Pitting corrosion is a localized metal loss that takes the form of subsurface pits of the various shapes, narrow and vertical, elliptical to shallow to the subsurface cavity, and horizontal shapes. It is restricted to single point of small areas and emerge in a random pattern. Pitting is a type of corrosion that occurs in materials that have protective films. It is an attack with localized holes on the metal surface. The attack can penetrate the metal very rapidly, while some parts of the metal surface remain free from corrosion. It is very hard to detect and prevent from the pitting corrosion. That's all from me. Thank you.
Okay, for the next slide is method of non-destructive testing. NDT test I will using a sonic testing is a non-destructive method used to detect pitting corrosion in material like metals. It works by sending high frequency sound wave into the material and analyzing the reflection to detect any corrosion. The test result show the extent and location of the corrosion. Okay, for this method is quite cost effective and non-invasive, making a widely used in industries such as oil and gas, power generation and marine. Okay, for the next slide is corrosion prevention method. Okay, for corrosion prevention method, it has six. For the first one is proper material selection, is selecting material that are resistant to corrosive can greatly reduce the risk of pitting corrosion. For example, using a stainless steel or aluminium alloy in an environment with high chloride level can help prevent corrosion. Okay, for the next is surface treatment. Okay, for the surface treatment is such as electroplating, anodizing or galvanizing can provide a protective barrier against corrosion. Okay, for the third point is maintenance and cleaning. Okay, for the maintenance and cleaning, regular maintenance and cleaning of the surface can help remove any corrosion causing agents and prevent pitting corrosion from forming. Okay, for the next slide, corrosion inhibitor. The use of corrosion inhibitor such as inhibitor in coolant or coating can slow down or prevent the formation of pitting corrosion. Okay, for cathodic protection is this method involves applying a direct electrical current to a metal surface to prevent corrosion by shifting the corrosion potential in a direction that prevent corrosion. Okay, for the last point is environment and control. Okay, for controlling the environment such as maintaining operation temperature and humidity level can reduce the risk of pitting corrosion. That's all from me. Thank you.